Let's go ahead and get started. So where we left off was synthetic strategies. And so as we talked about last time, you've got two basic things you need to be watching for. Carbon skeleton changes and two functional group changes. So when we look at functional group changes, one of the things that's very helpful to do, and our textbook actually can help you with this, is to, at the end of each chapter, the textbook has information on all of the reactions. And so if we look at this chapter 19, the one we're in currently, when we look at the review of reactions, it has a process where it looks at the functional group that we're in, and then it looks at all the reactions that we went. And so one of the things that you can do is go ahead and look at these in the chapter and kind of see what is happening. And so if we look at this one, we've turned a ketone aldehyde, right? So ketone or aldehyde. And we can see that we have now an ester, we have an alkene, and we can show all of the different functional group changes that we have. So there's a hydrate, I'll draw that in a minute. And of course, this gets pretty big. We've turned it into a we've added a carbon there. Here we've turned it into an alcohol. We've got our nitrogen species, our thiols, our ketals, and then a slightly different one, our enamines. So for each of your functional groups, the textbook has this, and it's a good thing to know, especially for this functional group changes. What it does is allow you to know where you can go, right? So here's a hydrate. Here is addition of a carbon. Here we got an alcohol. We got an imine and derivatives. Here we've got a thioacetal. We have an acetal, and we have an enamine. And so we can do this with many functional groups. And it's a good thing to go ahead and start doing this. And you noticed in this case, I've left out all of the reagents. So if we think about flashcards, you could have this as the front of a flashcard. Of course, it might be hard to get it on a little 3x5, but then on the back side, we convert that into now questions, right? So if we want to do the first one, that's going to be the Baeyer-Villiger, right? So CHO3H. And then if we want to get to the alkene, we're going to use the phosphorus ylide. Go into the hydrate, we'll use water and either acid or base. Going to adding the carbon, we're going to use the Grignard. And then neutralizing workup. We go to the alcohol. We're going to use sodium borohydride and methanol. Going to the enamine, right? We're going to use the NH2Z, meaning C could be an OH, could be another NH2, could be a methyl group, and then trace acid or catalytic acid. The thioacetal, we'll use the dithiol with the acid to get to the ketal. Right, we'll again use the dialcohol, and then to get to the enamine, we'll have the trace acid, and now the R2NH group, so the secondary amine. And so we could have this as the backside. Of course, here I'm doing it with a ketone. You can do something similar for the aldehyde. It's almost the same, except for you end up with the carboxylic acid here with the aldehyde. So let's take that out to be most exact. And then we could do the same thing with an alkene, right? So if we take an alkene here, right, this is something we could do when we look at these reactions. So if we go and look at the addition to alkenes, review of reactions. And again, it's in your textbook if you want to go back and look at these, but it's good to review this and kind of think about this in this kind of circular form, right? So we can take this double bond, and I'll go ahead and do something like this. So now this double bond, we could add and create, the OH. We could add the OH to the more substituted side. We could add a bromide. We can add the bromide to the more substituted side. We could make the ketone and aldehyde. We can make the dibromide. We can make the alkane. We can make the CHEM3153002. We can make the trans diol. Okay. We can make the halohydrin. Okay. So we've got all of these reactions, all right? And so we can start with one group here, alkenes, and we can form all these other functional groups, right? So this is the anti-Markovnikov alcohol. We got the Markovnikov alcohol. We've got the anti-Markovnikov halide. We got the Markovnikov halide. We got the ketone, right, and aldehyde. That could be two aldehydes, two ketones. We got the geminal dihalide. Got the alkane. We've got the cis diol. We got the trans diol. got the halohydrin. So if you go back through and look at all of your review of reactions, you'll see these. Again, it's drawing these out as I've done here. It takes time, right? It takes some paper. This will help you learn it. And again, what I would do now is I go back in and I'd put in my reagents as the reverse side. And I would do this for each of the functional groups. This is a good way for you to learn all your functional group transformations. And we think about our synthetic strategies, right? We're going to need to know those functional. What functional group can I turn into which other functional group? Carbon skeleton changes, we know that those are limited. So that's why that one's number 1. So if we look at 1 and 2, we need to plan out our carbon skeleton changes. So let's look at a change in functional group and a change in carbon skeleton. So if we look at this process, so we're going to go from here to here. Okay. Again, what we want to do is we want to look at 1 first. 1 is carbon change. So here, if we look at it, I see 7 carbons. And here I see 8 carbons. If we look at 2, right, 2 under this case, we're looking at functional groups. We see that we go from an alkane to an alkene, right? So we know that we're adding 1 carbon, right? And we know that we're going to also end up with a functional group change. Okay, so when we analyze this, okay, there's a little bit of help here, because if we think about alkanes, what can we do with an alkane? So if we think about this same little chart here, what can we do with an alkane? Well, we can take an alkane and I can add a halide. And really that's about it, right? So if we think about this process, right, we can just add Br2 and light, right? And we're gonna get a transformation to a bromide, right? But then the question is, what can we do with a bromide, right? Well, we could turn the bromide into a hydroxide, right? We take that bromide and eliminate it to give me this double bond. By changing my reagents a little bit, I could change it to that double bond, right? So I can get preference there. So for my halides, I've got a few things I can do with it, right? I can turn it into an alcohol. I can turn it into a double bond. If we think about what could get us reactivity at this position, right? Which of these 3 now gets me to reactivity at that position? So I've added the bromine. The bromine is going to go to the tertiary position. So that's going to be my favorite reaction. But then here, going to the alcohol, does that put any reactivity here? No, right? So I don't have any in there. I could, right, do a dehydration. Let me change my colors. Right, I could do a dehydration and end up with this species, right, which is similar to here. But now, right, this one, I've got a position where there's activity. Here, right, there's not. So these 2 being identical, both of these potentially get me to a place where I could do a reaction, right? So if I want to do the reaction, then what things will get me to the alkene by adding 1 carbon? So thinking about that, right, I've got carbon-carbon reactions. I've got Grignards. I've got acetylides. Got a Wittig reaction. Maybe cyano reactions. Okay. If we think about these, how many carbons am I adding? I'm only adding 1 carbon, and that turns out to be important, right? So I'm only adding 1 carbon. For an acetylide reaction, what's the minimum number of carbons? Well, an acetylide is a triple bond, right? So if we look at an acetylide, I have to add at least 2 carbons. So in this case, the acetylide is not a possible reactivity species. The Grignard, I could add the CH3MGBr, that could add 1 carbon. The Wittig, I could add the CH2 process right there, that could work. And then the cyano, right, only adds 1 carbon, but it also adds a nitrogen. But that's possible, right? So that one could add 1 carbon. I just have to later get rid of the nitrogen. Okay, now if we look at these 3 options, which of them gets us to an alkene in the least steps? Well, the one that gets us to an alkene in the least steps is the Wittig. So is there a way for us to go from this species here, or this species here, to the Wittig? Well, what do we need for a Wittig? For Wittig, I need to react. If I was going to add a double bond there, I'd need a carbonyl there, and then I could react that with my phosphorus ylide, right? And then that will get me to my final product. So is there a way to get from this alkene to, or this alkene to that alcohol, to that carbonyl? Well, yes, I could potentially take that to this, right? The anti-Markovnikov alcohol, and then I should be able to take the anti-Markovnikov alcohol to the ketone. So one of the things that you should think about when you're doing this, and I strongly encourage you to do this, is don't worry too much about your reagents. We've walked through this synthetic strategy, right? We've analyzed this product. We look to see what happens with our carbon skeleton and what's happening with our alkenes. And then we've walked through, okay, what are some of the possible things that are doing here? And again, you're not going to know these answers. You're going to process and figure out these answers, right? So you're going to work towards the answer. So I figured out a few things there. I've said, okay, what are my options with my carbon-carbon bond forming? Oh, look, the Wittig would be really convenient. Is there a way for me to do the Wittig? Oh yeah, there's a way to do the Wittig. And so now what I would do, instead of worrying about your reagents, right, I would just worry about the transformation steps. So I'm going to take this to the halide, right? I'm going to take the halide to the alkene. I'm going to take the alkene to the alcohol, take the alcohol to the ketone, and then I'm going to take the ketone to the product, right? Multiple steps, right? Then once you have this worked out, then you come back and start worrying about your reagents. How do we do this one? We're going to use bromine and light. How do we do this one? We need to do an elimination, and we need to do an elimination to the least substituted. Now this is the most stable, the most stable, the most substituted, but we can't use anything big and bulky because that will promote the Hoffman. So we need a Zaitsev. And so, we can use something small here. So sodium amine, or we could have just used, the potassium methoxide, right? Once we have this, then we're going to use the BH3 and THF, right? Followed by the hydrogen peroxide and base, right? To get the anti-Markovnikov alcohol. Anti-Markovnikov alcohol, I'm going to oxidize that up, and I can use several different things here, but I could use sodium dichromate and aqueous acid, right? Or I could have used PCC and methylene chloride, right, to get me the carbonyl. And then the last step, I'm going to use the phosphorus ylide with just the CH2 there, okay, to get me to the final product. Okay. Long process, right? But synthetic strategies, this is what we're working up to. We need to start to focus on these, okay? So let me put one down. I'm going to give you some time to work on it. So this is a video, so go ahead and pause the video and try it. Let's see what you can come up with. So take this alkene and turn it into this imine. So I'm going to assume that you paused. So if we look at one, right, if we look over here, we've got 1, 2, 3, 4, 5, 6, 7 carbons. On the other side, we have 7 carbons plus 3 carbons. Now, why am I putting them separate? Well, because we have the nitrogen in the middle, right? These 3 carbons are attached to that nitrogen. But if I look at this structure here, I actually haven't changed it, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The 3 carbons are attached to the imine, right? So that's a little different than what we saw in the first example. In the second step, right, we need to be thinking about functional groups. And here we go from an alkene to an imine. So since we aren't changing our base carbons, really what we're dealing here is just a functional group transformation. We're going to be turning an alkene into an imine, right? If we think about the ways that we can think about two possible ways to do this. We can start with, okay, how do I get to an imine, right? Well, you get to an imine by coming from a carbonyl, right? So I need the carbonyl to get to the imine, and that's really one of the only ways you know how to do that right now. Okay, but if we look at the double bond, then what can I do with the double bond? Well, I can do lots of things with the double bond, right? So I could add a halide to that. I can add a alcohol to that. I could turn it into the alkane. I could turn it into the epoxide. I could turn it into the geminal dialcohol, right? Same side there, so forth, right? But if we think about it, it's this one, adding that oxygen that looks the most the same there, and I can go from here to here. So again, we've got to think about the steps and think about the possible transformation. So looking at those review actions, having them handy with you, working through those, you can do it like I did here and kind of think about it from the top of your head. Okay, and then here, if we look, so this transformation, going back and looking at our molecule, I'm going to take this double bond. And again, don't worry about your reagents right off the bat. And I'm going to make this alcohol, and then this alcohol is going to turn into this aldehyde. And then this aldehyde is going to turn into my imine. So then first step, right? Now we think about our reagents. We need an anti-Markovnikov alcohol. So anti-Markovnikov alcohol is the BH3 THF followed by the hydrogen peroxide base in water. And then we need to oxidize that up, but we only want to oxidize the alcohol to the aldehyde. So I'm going to use PCC and methylene chloride, right? I need to make sure there's no water in my oxidation. So I'm going to use the PCC reagent. If you had learned the sworn reagent, you could have done that one as well. And then the imine, I just need my NH2, right, with the right number of carbons. That's where I'm adding my 3 carbons. And then I need an acid. All right, let's take another look. Let's try another one. Again, please pause the video, try the reaction, and see if you can. Okay, go ahead and pause. We're going to take this alcohol, turn it into the alkane. Okay, so let's take a look, right? We're going to the alkane. If we look at number 1, right, how many carbons? Here we have 6 carbons. Here we have 7, 8, 9, 10. We have 10 carbons. So we're going to be adding 4 carbons. we look at 2 here, we've got an alcohol going to an alkane. So in this process, right, we need a carbon-carbon bond forming reaction. And we've got a loss of an alcohol. So if we think, let's look at the carbon-carbon bond forming reactions, right? We've got Grignards, we've got the acetylide, we've got Wittig, we've got, let's see, sorry, forgot the other one. We got the cyano. This one's probably not going to be very useful, but the cyano reaction, right? And if we look at these, this one doesn't work, right? Because it only adds 1 carbon and then a nitrogen. So therefore I'd have to figure out a way to add more carbons. Could I add 4 carbons with Wittig? Yes, I could add, you know, we could add that. The illid, yeah, that would work. I would be adding something like this. And then the Grignard, you know, I'd be adding that. But if we think about what these will be adding to, right, all of these would add well to a carbonyl species, right? So that tells us what we're doing with our alcohol. Our alcohol is going to be doing carbonyl, and then we actually are going to have a few possibilities here. So we could take our alcohol, convert that to our ketone, and then our ketone, we could go to this species, right? We could go to that species, or we could go to, right, this one, right? So 4 carbons, right? So then we got these, and then we can think about which way that we're going to go. Well, this one, to get that OH off of there, we'd probably have to go to the double bond species, right? And then from there, we could go to the alkane. If we look up here, again, we probably have to go ahead and eliminate to give us this enamine, this enine, double bond and triple bond. And then we could take the triple bond to this. And then if we look here, we've already got that double bond. So all we'd have to do is reduce that, okay? So if we were looking at this one, okay, one of the kind of pseudo rules, rule of thumb per se, is that you want the synthesis that is the lowest number of steps. Now, that's not always going to be the best, but that tends to be the best, right? So if we look at it, going through the Grignard, right? So this is the Grignard path. We see that we get 2 more steps. If we go through the acetylide path, we also have 2 more steps. But if we go through the Wittig, once we've made that Wittig, all we have to do is reduce that double bond. And so that's the step that we're going to want, is that will favor, right? So if we come back in and put our reagents here, we just need the oxidation, right? And again, we can use several different conditions. This one works fine, especially for secondary. Then our Wittig, we want to put in the right number of carbons, right? And since the starting material is symmetric, we don't have to worry about E and Z. And then here, just we need hydrogen and palladium on carbon, right? We're just going to reduce that down. Okay. All right. So one of the things you're going to start to see as we work through these is you'll see multiple correct answers. And so that's one thing to consider as we're going through these, okay? Is that we'll have more than one right answer, okay? Now let's look at a couple more examples, or at least one more. So again, stop the process. Okay, so pause it and take a look at this one. We're going to turn this cyclic alkene into this dialdehyde, acyclic dialdehyde. Okay, so let's take a look. Now, to get the cyclic dialcohol, right, if we look at one here, and I keep changing colors on me, sorry, but this is 6 carbons, right? And over here we have 1, 2, 3, 4, 5, 6 carbons. So at first blush, right, we haven't changed anything, but it's a big deal that we went from cyclic, right, to acyclic. And I just realized we're not going to be able to finish this one until the next chapter, so I do apologize. We'll go ahead and take a look at it. No, I can find an answer to this. I can find an answer to this one using the chemistry we have. So if we look at the second step, right, we're going from a ketone to a di, right, to aldehydes. Right, but the big deal, right, the one we really going to need to worry about here is the fact that we're going from a cyclic to an acyclic. So we have to think about the ways that we could take a cyclic to an acyclic, right? And really what that means is that we're going to be breaking that bond. Okay, so what reactions do we know of that break carbon-carbon bonds, right? So one of those is ozonolysis, right? If I had this, I could end up with this, right? So that's one. Another one is Bayer vinegar. If I had this, I could end up with, is that right? 1, 2, 3, 4, 5, 6, 7. I could end up with this, and then what we'll see in the next chapter, we could turn that into this, right? And of course, the Bay of vinegar get us this, but this is chapter 20. So let's stay with the ozonolysis. So what we need to do is turn our alcohol, our ketone, into an alkene. It's an internal alkene. So what I'm going to do is turn that into a alcohol. So we take our carbonyl and take the carbonyl, turn that into an alcohol. I'm going to take that alcohol and eliminate it to the alkene, and then I can take the alkene and end up with my dialdehyde. Looking at our reagents now, once we've got it formulated, then we work through our reagents. First step, we're going to be doing a reduction. So we could use sodium borohydride and methanol, or I could have used lithium aluminum hydride. Right, first step, second step, water. Going from the alcohol to the alkene, we can do the dehydration with sulfuric acid, right, and a little bit of heat. Remove water and we'll get that. And then the final step, we're going to do ozonolysis. So dimethyl sulfide or zinc and acid to do the reductive ozonolysis, okay? So when we look at the synthetic strategies, right, you need to look at your carbon skeleton and you look at your functional groups. If you have not done so, right, I would go and look at your reactions. Let me get back up to that. Go look at the review of the reactions and start drawing out these processes and thinking about them as functional group transformations, right? And think about all of the reactions that you may have to form carbon-carbon bonds, okay? All right, with that, we'll go ahead and stop. We'll move into chapter 20, the next lecture.